So we're here to talk through this TomTom variation by Dan Katz that takes the normal concept of cage values, puts them into a cage pair, and forces us to actually choose an independent operation for this value versus the ones around it. And if you hadn't seen the example that went alongside this puzzle, the example may help you understand the rule. But in this case where we have these middle clues that just use ones and twos, those look pretty hard to use. These very big values are certainly be coming from a large product that's then interacting with a plus or minus to get to this stage. The largest product we can make in two cells is 30, so this is going to be a sure multiplication from the largest cage, and the largest product at all we can make is 6 and 5 and 6, which is 180. The next largest product we can make is 5 and 5 and 6, which is 150, and 150 is pretty far from 178. We couldn't get a two-value cage to get us something that would get us all the way up 28 more cells, because we can't use times again. So if this is a times, 178 is going to be coming from a minus, and this is going to be a 2. And the 2 can't be a plus. 1 and 2 is 3 is the smallest one, so this is a 2 division. So this is the way we can break into some of the puzzle as a large product, a something else that adds together or subtracts together to get to a 178. We'll put in the 665 that we know for sure. And now think over to this left side of the grid. We've got a 124. Again, this is going to have a large product around it, and the product is going to come through this 3-cell cage. The largest values that these can take are 5 and 4, and putting in a 6 here, we get 120 for this value. Notice if this were 5 and 3 with a 6, we would have something like 90, far too far from 124. If this were 5, 4 for another 5, we'd have 100, which is far too far from a 24. Again, if the times is already used, the largest value we can get from the rest is a plus, which is about 11. And that's not even thinking about the rows around. So this 120 is the only thing that looks reasonable. It's an extreme, which has 6 with 5 and 4 in these cages. The 124 is going to come from an addition, and this is going to come from a 4, which can be a minus or a division. Minus doesn't have any options left for it, actually. If the largest value is a 4 and the smallest is a 1, 3 minus would be the biggest subtraction we could get. So this is a 4 division, which is going to have 4, 1, 4, 1 in it, and that's going to get us across to the grid. We've got a 2, 3 left to place in this bottom row, and the 3 would form a 6 for a 2 division, but that's not going to work. So this is a 2, this is a 3. Notice the 4 is already in this row, so this is a 2 divided by a 1. We have a 2 and 3 left to place in this 5th row, and those have to go in these cells. And now we're going to come into the start of the 1-2 punch with this 12 clue and think about how do we get to a 12. And particularly here, we're going to have a cage that's potentially a 6 times. It's not going to be a division. It could be 1 minus, and it could be 5 plus. If this is 5 plus, to get to 12, this is going to have to be 7 plus, but we use plus twice. So this is not a plus cage. This is not a division cage. This could be a times or a minus. If this is a times, we've got 6 coming from here. We're going to have another 6 from there with a plus, but 3 something that's not a plus, not a times. We're not going to get large enough. And so even the times is not possible for this. So the only way this looks like it works is a 1 minus. And if that's a 1 minus, then this is going to be a value like 11 with a plus, but that's not going to work, or this is going to be something like a 12. And if this is a 12, it's got to come from a product, which means this 12 comes from a division. 12 divided by 1 is 12. That looks fine. And so we get this star of the puzzle. A lot of hard work to get to here, but some good progress that's going to get us through to the next stage of the grid. Maybe a few cells we can mark. We've got a 3, 5 here, a 1, 2, 3 here, 1, 2, 5 here, 1, 2, 3, 4 here. There's a little bit you can think around the 21. Like 21 could be 3 times 7. It could also be like 20 plus 1, 24 minus 3. There's sort of different options here. Looks like the largest product is 20, and that would leave like 20 and 1, get to 21. We have 35 with 6, some other sort of options. 3 and 5 would give us 15. But I guess we can't have 3 times 5 and work to this. But before we move too far away from it, I want to come back to the next largest big product. And this, again, looks like it's going to have to be a product in the 3-cell bending cage. And remember that a 94 is going to be a plus or a subtraction from another clue. And the largest delta we can have in a sum is going to be something like a 4 with a 6, or kind of 10 away. So we're kind of going through a range from 84 all the way up to the largest subtraction we can have. Again, going to be coming from something like an 11 or a 10. is going to be 104. So there aren't a lot of products that make sense in this range. Actually, you'll see that the largest odd product we can make is 3, 3, 5, 45. So these will always be the even products we need to look at. 84 has a factor of 7, is no good. 86 has a factor of 43, is no good. 88 has a factor of 11. 90 looks very possible. 90 is going to be, in this case, 5 times a total of 18. That 18 is going to need to be a 3 with a 6 in this puzzle. So that's a good option. 92 doesn't look good. It's got a factor of, what is that, 46, 23, so 23 is a prime that's not going to be able to do a product. 94 has a similar issue. It also would need a 0 in the other cage, which is going to be a value we can get with the constraints in this puzzle. 96 looks reasonable. 96 with a 2 minus would be possible. And 96 could come in a few ways. This largest value in the cell looks to be a 4. If we do have a 4 here, we have 24 left over. So 4 times 4 times 6 looks good for it. If this gets smaller than a 4, then this product has to be larger than 24, and it's not a 30. So this is the only way you can get a 96 to work for this. 98 is going to have 2 factors of 7. That's not going to work. 100 would have to be 5 times 5 times 4, but there's a 5 in this column. 102 has 51, which has 17, a prime we don't have. 104, kind of the upper limit we were looking at, is going to have a prime of 13 in it. So these look to be the only 2 options we're thinking about. All of them include a 6 in the cage, and the cell is going to be a 3 with a 4, and these cells will be, in this case where this is a 3, this will be a 5 with a 6 or a 4 with a 6. So there's 4, 5, 6, 4, 5, 6 as the options here. Now, if this is a 90, then this is going to have to be a 4 value, and this is going to have to be, if this is 90 plus 4, this is going to have to be a minus or a division. And if this is 96, this is 96 with a 2 minus, and so the other way this goes is this is a 2, but this is now a plus, and that doesn't look possible, or this is a 2 division. And I think one of the things that's going to play out as a constraint is that 2 division is pretty tough to do. So let's look at that 2 division first. And that 2 division is forced if this is 4, 4, 6. If this is 4, 4, 6, then we're left with 3 and 5 as the digits that go into the space. If this is a 3, it has to go with a 6 to be a 2 division. That's not working. And if it's a 5, there's nothing that makes it a 2 division. So we can cancel out the 2 option. This has to be a 4 with some product around it, but the 90x is the right one for the grid. And that puts in that we have a 3 in this big cell. We have a 5, 6 pair here, which eliminates this. This is a 4. This is 94 plus, so this is 4 minus or 4 divides, but once you have a 4 here, this has to be 4 divides, which makes this a 1. We have 2 and 4 left to place in this column, so that's this and this. And now we have still 1, 2, 5. We have 2, 5, 1, 2, 5. We should notice we've got 3 4s here and 2 4s here, so the last 4 in the grid is in this cell. And I think with that, we can start to convert back to maybe looking at some of these other clues. We also have a 1, 5, 1, 5 in this row to finish it out. Notice we now actually have a triple, so 2, 3, 6 is what's left up here. So got a cell like that, it's got to be a 2, 6. And I'm just seeing if there's anything else that's kind of quick and easy to work with. But I think this is a good stage to come back to this 21 clue. We now have a cage that can be a 1 or a 5 or a 6, and it can't be a division. If this is a 6, that's going to mean this needs to be 15 and this 21 gets from a plus. That looks very bad. If this is a 5, this is a 16, again, has to get it from a plus. That looks very bad. 1 is interesting. 1 would leave behind 20 or 22 here, and 20 looks like a credible version. So if this is 20 and this is 1 minus, then 21 plus gets us a valid shape, and that looks to actually be the only way that goes. So we get this 5 puts in this 5, 6. We now have a sure 1 here and a sure 2 here. This row has a 2, 6 to finish it, which go in these cells. This row has 1, 2, 3 to place. This is the last spot for a 2. This is a 1. This is a 3. This column now has 5 and 6 to go. This forces the last 1, 1, 4, 4, 5, and 5, 3. And at least in my solve, I didn't go through any of these clues on the left side of the grid, but let's just come back and validate they work. This can be 11 plus with something like a 5 divide and a 6 times, so that looks reasonable. This is 4 and 3. Let's make this a 4 divide and a 3 plus equals 12 times. This 36 is always going to be coming from a large product on the side, but this large product is actually 36 and 3, 108. So this is a division, and it's dividing from 3 minus. So there we go. We've got a full solution to the grid as well as a full marking of all the cages and values. At least in my solve, it started by focusing on these 2 large values in the bottom, getting the extremes that get us into the grid, taking out this 12 divide, gets us some headway. And then I was just exploring the 2 options around this 94 clue, the 90 and 96. The 90 is the only one that worked out for me. And that got me to my solution. So hope you got something from watching my solve of this video. If you have other suggestions for this puzzle or things you ran into your solve, we'd be curious to hear about those too. And we'll see you again soon.